Good morning, students. Today we are going to discuss the chapter Surface Area and Volume. And in this chapter, we are going to discuss exercise 13.4 last three sums. So let us go through these last three sums and see their solutions. Question number 7 says, the diameter of the moon is approximately 1/4 of the diameter of the earth. Find the ratio of their surface areas. So we know that the moon and the earth are spherical in shape. So the diameter of the moon and the diameter of the earth is provided, and we have to assume one of the diameter first and find the other diameter. And then we will find the ratio of the surface areas. So for pi, we know that for spheres, we know that the surface area is 4 pi r square. 4 pi r square. So this is the surface area for the sphere. We will use this formula. So let us see how the sum is being done. Let the diameter of earth be x. So now the diameter of the earth is x. And the diameter of the moon will be 1/4 of x as given in the question. So it will be x by 4. So from diameter, first we need to find the radius. Hence the radius of x will be x by 2, as half of the diameter is the radius. So for earth it will be x by 2. And radius of the moon will be half of the diameter of the moon, that is half into x by 4, which is x by 8. Now the ratio of the surface areas will be surface area of the moon by surface area of the earth. So the formula for surface area of the moon, as they are sphere, will be 4 pi radius of moon square by 4 pi radius of earth square. So here we have written in words like radius. You can denote the radius of earth as capital R and the radius of moon as small r. So radius of moon, 4 pi into radius of moon whole square and 4 pi into radius of earth's whole square. As you can see, 4 pi, these two terms are common in numerator as well as in the denominator. So we can cancel them off and we will get radius of moon whole square by radius of earth whole square. Or in symbol form, if we write, we can write small r square by capital R square. So the radius of moon is x by 8 whole square. And radius of earth is x by 2, so x by 2 whole square. So we can write x square by 8 square by x square by 8 square. Now the denominator is again in fraction as well as the numerator. So we can write it in reciprocal form. So the numerator will be written as x square by 8 square into the denominator will be inverted and be written as x square into 2 square by x square. Now the x square and the x square can be cancelled and we will get 4 by 64. 4 by 64. If we simplify or cut, as 64 is a multiple of 4, so we will get 1 by 16. So the ratio is 1 by 16. This is our answer. So the ratio of the surface areas will be 1:16. So this was question number 7. Now let us see question number 8. A hemispherical bowl is made of steel of 0.25 centimeter thick. So now our hemispherical bowl is 2.05 centimeter thick. The inner radius of the bowl is 5 centimeter. So the outer curved surface area of the bowl will be, first of all, we have a hemispherical bowl. So for the formula, we will use 2 pi r square. And the bowl is a little bit thick. So the thick part is given as 0.25 centimeter and the radius of the inner part is given as 5. So this portion is 5 centimeter. So we have to find the outer curved surface area. That means we have to add this full thing. So it will be our new radius, and hence we will find our curved surface area of the hemispherical bowl. So let us see. As you can see in the diagram, the inner part is 5 centimeter and the outer portion is 0.25 centimeter. So when we add up, the new radius is 5.25 centimeter. We need to find the outer curved surface area, hence we have to find the outer radius. So inner radius is 5, outer radius will be 5 plus 0.25 centimeter. So our new radius is 5.25 centimeter. And the outer curved surface area, the formula is 2 pi r square. So in place of pi, we will assume 22 by 7 and r will be 5.25. So substituting all the values, now this point can be removed and written as 100. Again this point can be removed and written as 100. 7 and 525 are multiples of each other. So we can write 7 sevens are 49, so 35, so 75. So we can cut 7 and write 1, and 525 we can cut and write 75. Now no need to cross out the denominators. Let them be there, as the shifting of point will be easy. After this simplification, we will multiply 2 into 22 into 75 into 525. The answer will be, and then divided by 10,000. So the answer will be 173.25 centimeters square. So this will be our outer curved surface area of a hemispherical bowl. Next, question number 9. And the last sum of this chapter is 9. So question number 9 says a right circular cylinder just encloses a sphere of radius r. So this it is shown in the diagram. So as you can see, this is the cylinder in which a sphere is inserted. So the largest diameter of the cylinder will be the diameter of the sphere, and the radius is given as r. Radius of the sphere is given as r. Find number 1 surface area of the sphere. So we will just substitute the formula. Curved surface of the cylinder, so we need to find the radius as well as in h, that is the height. And third part is the ratio of the areas obtained in subpart 1 and subpart 2. So let us see how to do this sum. Now the first subpart was to find the surface area of the sphere. In the question it was given the radius of the sphere is r. So the surface area of the sphere will be the formula 4 pi r square. So it is as simple as that. No numerical value is need to be substituted. For pi also there is no need to substitute the value, because at the end we are going to find their ratios. So they are going to cancel each other off. So no need to substitute the value for pi. So the first subpart answer will be 4 pi r square. Second subpart says we have to find the curved surface area of the cylinder. Now the formula for curved surface area of the cylinder is 2 pi r each. The radius of the cylinder is obviously the radius of the sphere, as the sphere is inside the cylinder and the maximum portion is covered. So the radius of the cylinder will be equals to the radius of the sphere, that is r. Now if this portion is r, obviously the radius is included at top as well as in the bottom. So the height will be equal to the diameter of the sphere. So the diameter will be 2r. So height of this cylinder is twice the radius, so height h is equals to 2r. Now we will substitute the value of h and r in the formula 2 pi rh to find the curved surface area. So we will get 2 pi rh is the formula. Then in place of r we are going to substitute as r only. H we are going to substitute 2r. So we will get 4 pi r square. Again over here no need to substitute the value of pi, as in the third part of the solution we are going to cancel it off, as we have to find the ratio. So leave it as pi only. So answer will be 4 pi r square. And the last part says find the ratio of the areas. So ratio will be surface area obtained in subpart 1, that is surface area of the sphere, by the surface area of the cylinder, that is obtained in part 2, which is 4 pi r square is the surface area of the sphere obtained in 1, and 4 pi r square is the surface area of the cylinder obtained in 2. So all the numbers, that is 4 pi and r square, cancels each other off, and we will get 1:1. So the ratio is 1:1. So these are the 3 sums from exercise 13.4, out of which question number 9 and 7 is very important. I hope this short tutorial is helpful for you. Thank you.